Okey, kita ambil contoh example 1. Okey, dalam example 1, kamu dibagi 8 gas molekul yang bergerak secara random. Okey, dan masing-masing mempunyai hal laju yang berbeza. Okey, dalam soalan ni apa yang kita nak ialah determine the mean speed of the molecule. Mean ni maksudnya ni purata. Mean purata speed. Purata ni maksudnya jumlah, kita jumlahkan semua sekali 8 molekul ni bahagi dengan 8 gas molekul. Okey, mean square speed maksudnya purata kita kuasa 2 semua sekali hal laju dia setiap satu ni, kemudian kita bahagi dengan 8. Dan juga okay, ini simbol untuk mean speed. Okey, mean speed ni ialah begini. Mean speed ialah sebegini. Okey, bracket V bracket. Okey, dan juga untuk mean square speed maksudnya bracket macam ini V square. Okey, kalau root mean square speed maksudnya di sini macam ini. Root mean square speed. Okey. Jadi kita pergi kepada penyelesaian. Pertama sekali kamu kena senaraikanlah bilangan gas. Ada 8 gas molekul di situ, dan bila mean speed ialah of the molecule is given by mean equal tu jumlah keseluruhan hal laju dia bahagi dengan 8. Jadi kamu akan dapat 2.5 meter per second. Okey, ini untuk mean speed. Okey, mean speed. Kalau ingat ini ialah simbol bagi mean speed. Okey, dan seterusnya kita pergi kepada mean square speed of molecules is given by okey, jumlah setiap satu hal laju tu, speed tu, kemudian bagi dengan 8 juga, kita akan dapat 8 meter square per second square. Okey, bila root mean square speed ialah VRMS. Okey, ingat root mean square speed istilah dia ialah RMS. Jadi ialah sama dengan punca ganda mean square speed. Okey. Okey, jadi kamu daripada nilai di atas kamu masukkan, kamu akan dapat VRMS sama dengan square speed 8. Square 8 So it become 2.83 meter per second. Okey, untuk example kedua, a cylinder volume. Okay, you are given a cylinder volume 0.08 meter cube contain oxygen gas at temperature 280 Kelvin and pressure 90 kilo Pascal. Maksudnya di sini 90 times it with 10 power of 3. Determine the mass of oxygen. Mass of oxygen maksudnya M lah. Okay, number of oxygen molecules dia nak N. Okay. Okay, root mean square speed maksud di sini ialah VRMS. Okay, jadi dalam soalan ini anda diberilah beberapa permala penting. Pertama sekali R, kedua K, dan juga molar mass oksigen, dan juga nombor Avogadro. Jadi apa yang penting dalam soalan ni, kelas, kita senaraikan apa yang dibagilah. V sama dengan 0.08 meter cube, T sama dengan 280 Kelvin, pressure it is 90 times 10 power of 3 Pascal. By using equation state, PV equal to nRT, and N ni ialah mass of gas divide by molar mass. Okay, jadi kita masukkan nilai N tu, mass of gas over molar mass time it with RT ya. Okay, jadi kita masukkan nilai, kita akan dapat mass of gas 9.90 times 10 power of negative 2 kilogram. Okay, number of oxygen molecule in the cylinder is, okay, N equal to mass of gas over molar mass equal to number of molecules. Ini number of molecules. Ingat N besar. Okay, tolong ingat kalau N besar ni number of molecule je. Okay, jadi kita nak number of molecule. Jadi kita dah berjaya dapatkan mass of gas. Kita bahagi dengan 32 darab 10 kuasa negatif 3 kg kan. Darab dengan Na. Okay, Na 6.02 darab 10 kuasa 23. Jadi kita akan dapat N sama dengan 1.86 darab 10 kuasa 24 molecules. Okay, root mean square ni maksud di sini ialah VRMS equal to square root 3RT over M. Okay, jadi memandangkan ada beberapa perkara lah yang dibagi dalam tu. Ada yang pemalar, ada yang dibagi dalam soalan. Okey, jadi kita masukkan nilainya, kita dapat VRMS 467 meter per second. For example, okay, example 3, a vessel contain hydrogen gas. Hydrogen gas, dia bagi kat sini hydrogen gas ni apa? It is monoatomic. Maksudnya bila monoatomic, F dia ialah 3. Okay, hydrogen gas of 2.2 times 10 power 18 molecules. Maksud di sini dia bagi N dia ialah, okay, sorry ya, N it is 2.2 times 10 power 18 molecule per unit volume. Okay, dan juga dia bagi kat kamu kat sini, okay, oh sorry, N over V. Okay, dia juga bagi kat kamu mean square speed. Mean square speed of molecules. It is 4.5 km per second at temperature 50 degrees Celsius. Determine the average translational kinetic energy of a molecule for hydrogen gas. B, pressure of hydrogen gas. Okay, you are given that G, molar mass. Molar mass of hydrogen gas, it is 2 grams. Okay, 2 gram per mole. Okay, number of Avogadro. Hydrogen mono ke diatomic? Sekejap, nanti kita tengok. Saya lupa lah kelas. Okay, sekejap Okay, jadi kita senaraikan apa yang dibagi dalam persamaan ni. Hydrogen. Sorry buat pembetulan sikit. It is diatomic. Okay, jadi N over V it is 2.2 times 10 power 18. Okay, jadi V apa? Dia bagi kat sini mean square speed it is 4.5, convert kepada meter lah, 10 kuasa 3. T kamu convert lah kepada Kelvin, akan jadi 323.15. Jadi kita nak average translational kinetic energy of a molecules is KTR equal to 3/2 KT. Okay, kamu masukkan nilai dia K K 3/2, K it is 1.38 times 10 power of negative 23 times weight 323.15. Okay, jadi kamu akan dapat KTR it is 6.69 times 10 power of negative 21 joule. Okey, jadi untuk dapatkan pressure, kita masukkan nilai dia lah dalam persamaan ni. Just masuk teruslah. P it is 1/3, 2.2 times 10 power of 18 times it with mass. Mass of hydrogen time it with mean square speed. Okey, jadi mass ni sama dengan molar mass divide by NA. Sebab apa? Daripada mana datang persamaan ni? Datang daripada ini ya kelas. Molar mass M time it with NA time equal to molar mass. Okey. Okey, jadi kita masukkan dalam persamaan ni. Okey, jadi dia akan jadi begini ya. Masukkan nilai dia. P equal to 1/3 N over B, M molar mass over number of Avogadro time it with mean square speed. Okey, jadi kamu akan dapat nilai dia ialah pressure it is 1.10 times 10 power of negative 5 Pascal. Kita pergi kepada soalan seterusnya, Mei 2009-2010. Okey, soalan nombor 17. Okey, slide 17 Okey, dalam soalan ni dia bagi kamu molar mass of the gas. Okey, molar mass of the gas it is 32 grams. Okey, dia bagi kamu temperature it is 300 Kelvin. Okey, jadi apa yang soalan ni nak ialah VRMS. Bila sebut VRMS sama dengan square root. Okey, 3RT over molar mass. So it is square root 3 times it with R it is 8.31 times it with 300 Kelvin. Okay, divide by molar mass dalam bentuk kg. Itu kita convert lah, 32 darab 10 kuasa negatif 3 kg. Okay, so kamu akan dapat nilai dia ialah VRMS sama dengan 483 meter per second. Okey, meter per second Kemudian dia nak internal energy of 3 mol oxygen. Jadi U it is F over 2 nRT. Okey, jadi di sini dia bagi 3 moles. So oksigen ni ialah diatomic. Oksigen it is F dia ialah 5 So F over 5 over 2 time it with 3 time it with 8.31. Okay, time it with 300 Kelvin. So kamu akan dapat nilai dia ialah 18.7 kilojoule. Okey. Okay, ini untuk Mei 2000. Okey, kita pergi soalan seterusnya untuk Mac 2002 2003 Okey, dalam soalan ni apa yang dia bagi? Dia bagi a nitrogen gas. A nitrogen gas ni ialah diatomic lah. Okey, diatomic nitrogen gas F dia ialah 5. Kenapa? It is diatomic. Okay. Dia bagi kat sini nitrogen gas of 14 grams is filled into a container at STP. Bila STP mean that temperature it is 0 degrees Celsius or 273.15 Kelvin. Okay, calculate the internal energy of this question. Okay, jadi kita kira dulu bilangan mol dia, mass over molar mass. Mass it is 14 grams, molar mass it is 28 grams. So it is 0.5 mole. So to get the value of degree of U it is F over 2 and RT. Okay, F it is 5 divide by 2 and it is 0.5 times it with 8.31 times it the temperature 273.15 Kelvin. Okay, jadi kamu akan dapat U dia ialah 3,800 2,837 joule. Okey, boleh kelas? Okey, kita soalan sama juga. Calculate the internal energy, sama juga soalannya. Okey, sekarang kita pergi PSPM 2002. Okey. 2002 kan. Okey, dalam soalan ni dia bagi kamu bilangan mol N sama dengan 0.3 mol. Okey, dia bagi kat sini nitrogen gas. Bila nitrogen gas ataupun N2, it is diatomic. Bila diatomic, F equal to 5. Okay, and then after that dia bagi kamu VRMS equal to 180 meter per second. Okay, dia bagi molar mass it is 28 grams per mole. Okay, jadi apa yang soalan ni nak ialah dia nak nilai bagi apa kat situ. Okay, what is the internal energy of the system if root mean square speed of nitrogen is 180 meter per second. Okay, sekejap Okey, persamaannya bermula begini Kita nak mulakan penyelesaiannya macam ni. Okey, jadi VRMS sama dengan square root 3RT over molar mass. Okey, jadi VRMS square equal to 3RT over molar mass. Okey, jadi RT equal to RT equal to 1 over 3 MV square RMS. So kalau kita nak jadikan RT ni sebagai tajuk, jadi U sama dengan 5 over 2 nRT. Okey, sama dengan 5/2 and it is 0.3. RT it is RT mean that dia diharap dengan apa, 1/3, isn't it, mVRMS square. Okey, dia akan jadi begini, 5/6 darab dengan 0.3 darab dengan mVRMS square. Okey, jadi kamu akan dapat U sama dengan 227 Joule.
Okay, now we discuss the problem related to thermodynamic process. This PV graph shows the combination of many thermodynamic processes. There are 5 processes according to the number of arrow. Process AB, process B to C, process A to C, process A to D, process D to C. When the gas expands from state A directly to C, the total quantity of heat absorbed by the gas is 10 kilojoule absorbed by the gas. So QAC is equals to positive 10 kilojoule. Determine A, the change in the internal energy of the gas delta U A to C. B, the total quantity of heat transfer to the gas if the following path of the process are taken: 1. Path A, B, C. 2. Path A, D, C. Solution A. To find the change in internal energy delta U A to C, first we have to calculate the work done A to C. The work done A to C is equals to the area under the trapezium below line AC. We go to the graph. So we have to calculate the area under the graph A to C, this trapezium area, is equal to 1/2 times in bracket 3 times 10 power negative 2 minus 1 times 10 power negative 2 times in bracket 8 ATM plus 2 ATM. We have to convert ATM to the SI unit Pascal, which is 1 ATM is equals to 1.01 times 10 power 5 Pascal. So we got the work done AC in SI unit Joule, positive 1.01 times power 4 Joule. Now we go to the first law of thermodynamic. Q is equals to delta U plus W. So QAC is equals to delta U AC and W also A to C. So delta U A C is equals to QAC minus WA to C. QAC mentioned in the question is equals to positive 10 kilojoule. So we substitute delta U A to C is equals to negative 0.1 kilojoule. Internal energy decreases when the gas expands. T final, T at C, is less than T initial, T at A. So decreasing in temperature, we get the answer is negative sign for delta UAC. Question B. the total quantity of heat Q. So we have to calculate Q A B C and Q A D C. The first step, we have to calculate the work done. To calculate Q A B C, we have to calculate the work done A B C, which is equal to the area of rectangle below line A B C. Rectangle, line A B C. So this area is equal to 8 times 1.01 times 10 power 5 times 3 times 10 power negative 2 minus 1 times 10 power negative 2. 8 is ATM. We have to convert to Pascal times 1.01 times 10 power 5. So we get Q ABC is equals to 16.1 kilojoule. The change in internal energy delta U is independent of the path taken. It is depend on the final temperature and initial temperature. So delta U A to C is equal to delta U ABC also is equal to delta U in change in internal energy ADC is equals to negative 0.1 kilojoule. So by apply the first law of thermodynamic process, QABC is equals to delta UABC plus WABC is equal to negative 0.1 kilojoule plus 16.1 kilojoule. So we got QABC is equals to 16.0 kilojoule. Question C. To calculate QADC, so the first step we have to calculate the work done ADC, which is area under the rectangle below line DC. If we refer to the PV graph, work ADC is area under the graph DC, this area. So area of rectangular below line DC is equal to 2 times 1.01 times 10 power of 5 times 3 minus 1 times 10 negative 2. So we got 4 kilojoule. Then apply the first law of thermodynamic process. QADC is equals to delta UADC plus work ADC. Negative 0.1 kilojoule plus 4.0 kilojoule. We got the heat energy for path ADC is equals to 3.9 kilojoule. Okay, example 4. Look at this PV graph. Pressure in unit kilopascal. Kilo is times 10 negative 3. And volumes in unit cubic meter. So we got 4 process, 4 arrow, process A to B, process B to C, process C to D, and process D to A. A vessel contains an ideal gas in condition A, as shown in the figure 14.3. When the condition of the gas change from A to B, the gas system absorbs a heat of 2.55 kilojoule. So 2.55 kilojoule is Absorb is positive sign for Q. So QAB is positive 2.55 kilojoule. When the gas in condition B changes to C, there is a heat transfer 5.32 kilojoules. So QBC is equals to 5.32 kilojoule. Calculate A, the work done in the process ABC. So if we refer to the PV graph, work done ABC. Work done is the area under the graph. A to B, B to C. So two process. So work done ABC is equals to work done process AB plus work done process BC. Work done for process AB is equal to 0 because if we refer to the graph, PV graph A to B, there is no area under the graph. So work done A to B is equals to 0. Work done plus work done BC. Work done BC is the area under the graph. This area for BC. So this area. So is equals to 150 times 10 power negative power 3 for pressure, times in bracket 3 times 10 power negative 2 minus 2 times 10 power negative 2. So we got work done ABC is equals to 1500 joule. Question B, the change in internal energy in the process ABC. So delta U ABC. By applying the first law of thermodynamics, the heat for process AB to C ABC QABC is equals to delta U ABC plus work done ABC. QABC, okay, delta U ABC is equals to QAB. QABC is equals to QAB plus QBC minus work ABC. Given in the questions, QAB is equals to 2.55. We convert to the SI unit, kilo. So 2.55 times 10 power 3 plus QBC 5.32, convert to the SI unit, times 10 power of 3 minus 1500 joule. So we got internal energy delta U ABC is equals to 6370 joule. Now we go to question C. The work done in the process CDA. The work done in the process CDA is W CDA. We refer to the graph CDA. From C to D, D to A. So work done is the area under the graph. Area under the graph CD, same with A to B. There is no area under the graph because volume is constant, isovolumetric or isochoric. So work done W C to D is equal to 0. Work CDA is equals to work CD plus work DA. So we have to calculate work DA, area under the graph, this area. Okay. So work CDA is equals to work CD plus work DA. Work CD is equal to 0 because constant volume, there is no area under the graph. So work CDA is equal to pressure at D times delta V, the change in volume, V final, VA minus V initial, V at D. So substitutes pressure at D 100 times 10 power 3 times 2 times power negative 2 minus 3 times power negative 2. We got Work done CDA is negative value, negative 1000 joule. Okay. Question D. Question D. The total amount of heat transfer in the process CDA. Q CDA. So we have to refer to the first law by applying the first law of thermodynamic process for CDA. So Q CDA is equals to delta U CDA plus W CDA. Delta U CDA is negative value. Delta U ABC is positive because temperature increases. Temperature increases. T at C, T at A, which is T at C is greater than T at A. So delta U CDA, okay, T at C, T at A. Delta U is depend on the final and initial temperature. The magnitude of delta U same, but the sign is different. Delta U CDA is negative because decreases in temperature. Final temperature T at A is less than initial temperature T at C. So negative value, which is equals to delta U CDA is equals to negative delta U ABC. So by substitute, Q CDA is equals to delta U, negative delta U ABC, negative 6370 plus work done CDA plus minus 1000. We got heat energy process CDA is equals to negative 7370 joule.